In this video, we are going to discuss the types of fossilization. As a warning, this video may be more educational than it is entertaining. What you can see in front of you is a list of some of the more common types of fossilization. Now, we see this whole list here. A couple things to keep in mind. Some of these types will be more common than others. Some are dependent on, based on what kind of material the original material is, so the original fossil aspects behind it. Other aspects that can include be what impacts we have with the water, chemistry. So when we take a look at some of these examples today, keep in mind that we're trying to keep this simple just to illustrate a couple of the key concepts. So we start off with permineralization. This is simply the filling in of pore space. We have water moving through the area because dissolved ions in it, again, be precipitated out into our pore space. This is relatively common in bone and wood. Permineralization is probably one of those fossilization types that you're more common or you would think of, especially if you've ever been to a museum or you've seen a fossil wood display. So when we look at this here, we can see an example of fossilized wood. We can see that not like you would expect from, like, say, a modern example here where you could see the grain structure better or even the pore spaces in it. You can see that everything has been filled in. We want to look at another common example. Let's take a look at a chunk of fossilized bone. So this is the internal components of our bone. Again, if you were to think about what a bone looks like, hollow spaces, the trabecular bone, things of that nature, I would expect to see some kind of pore space. Well, in this one here, you can actually see some of the minerals that have been precipitated out actually catch the light. Another way to identify permineralization is also by the weight of the specimen. Again, since there's no pore space, all the extra mineralization that's been filled in actually adds weight to your specimens. Now, if we look at our next one, recrystallization, this is a very common type, especially when it comes time for shells and things made out of calcite. The most common example of it, or the most common example you may ever read about, is where we get what we call the aragonite to calcite recrystallization. So you get that mother of pearl appearance being recrystallized into a more stable form of calcite. Now, recrystallization is kind of difficult to see in the macro scale, so actually the fossils, with the exception of trying to identify very delicate or fine features. Recrystallization usually removes that from the macro scale. So if we want to look at an example of recrystallization, here we can see we have a fossil horn coral here coming down to the apex. You can see some of the pattern on here loses some of its detail as a result of recrystallization. Now, if we want to take a look at my favorite type of fossilization, replacement. This is the process where the original material has been replaced by some other mineral aspect with it. So there's nothing, even remotely aspects of your original remaining. So if we look at an example of replacement, here's a brachiopod. So again, we can look at it, we can still see the hinge line, we can still see the symmetry that we get coming through our fossil like this. We can see the fold and sulcus, we can even see the ridges and the growth lines in our brachiopod specimen. But while I'm turning it around, it may be catching a light and look like it's made out of gold. Well, it's not actually gold, it's fool's gold, it's pyrite. So all the original material that made up this brachiopod has been replaced molecule by molecule with pyrite. So we end up with what we call a pyritized brachiopod. So all replacement. Now, if we look at carbonization, this is a very common aspect when we look at plants and some insects where the hydrogen and oxygen are preferentially removed after the specimen has been buried. So we want to take a look at an example here. Here we can see a carbonized plant fossil. So you can see your stem, your leaf structure through this. And again, all the hydrogen and oxygen has been preferentially removed through the burial and heating process going with this. Again, very common amongst most of our plants. Even some of our insects will go through that carbonization aspect. Now, if we start to look at a couple of the other aspects with fossils, we can get what we call mold and casts. We can think about mold and casts similar to what you would get at a dentist. So if you've ever been to the dentist and they've ever taken a mold or an impression of your teeth, they're trying to take a mold of it so that they can later make a cast or a replica of what your teeth look like. Now, let's take a look at one of the molds that I made from my own research process here. So on the inside here of this silicone mold, you can see the imprint or the impression of what's called the hyoid bones in a fossil horse. I made this for one of my research projects, but this gives you an idea of what a mold would look like. So we had an impression made of my fossil bone structure. Again, I can do this, fill it with an epoxy or other aspect, and make an actual cast replica. Now in real life, we want to take a look at a couple internal molds or internal casts here. Here we can see from a bivalve shell, we got two examples. Again, we can see the plane of symmetry going through the two halves as opposed to perpendicular, as was in that brachiopod. And again, this gives us the internal side of it. Sometimes these internal replicas are called Steinkerns, but again, falls under that internal molds and cast component. Now, last but not least, out of this topic we're going to discuss is trace fossils. Trace fossils are not an actual representation of the animal, so it's not part of the bone or hair or unearthed remains or anything like that one. It's evidence left by an organism. So anytime you have walked outside, left a shoe imprint or a foot imprint, or been walking on the beach, drug something on the ground, maybe doing yard work and you drug the spade across it, if that were to be preserved, you would have an aspect of some kind of trace fossil showing evidence that is there. Now let's take a look at a couple of the more common ones that I like to talk about. So here, this is a coprolite. This is a fossilized feces. So again, it's not actually representations of the animal. It's not actually parts of the animal. It's a byproduct of what the animal makes, so coprolite, fossilized feces. But again, can provide lots of details about what the animal ate, chemistry, aspects with that. If we want to look at another common one as well, here we can see what we call skeletals burrows. This is a type of organism that would burrow through your substrate and again can be filled in. We don't have an idea of what the organism was here, but this is evidence that it lived in this area, which can give us ideas about depositional environments or other aspects of the rocks. So with that being said, that's our brief description on types of fossilization.